Hey, hello everyone to the first Gopher Lab conference, and uh, this is a conference site and just let me check my screen. Okay, so let me walk you through the conference site. So we have a special guest from Facebook. I'll be speaking around a cloud native, and we have other speakers, so you can go check it out. Link in the description below for this conference website, so you can check it out, all the schedule and tracks. We have a lot of great sessions today. So this is all about conference. So let's talk about a little bit about community, Gopher Lab community. Gopher Lab community is on a Discord. Today we have more than 600 community members who actively contributing to the documentation, sharing the knowledge, and a lot more. So this is the website driven by the community, and we have more than 600 tutorials for the just a teaching, helping other Go developer to succeed in their career, and making sure that everyone learn together and grow together. Um, and you can go to the website. You can check on the screen. It's scrolling down, gopherlab.kubdelhi.com, and you will go and you can join a community or click on get started. It's a free training material, and it's a fully open source. We are adding more and more examples here, and more episodes, Gopher Lab episodes. Go and check it out, and you can try all the lab practicals, and you can ask anyone in the community, so they can help you out. I'll be there. You can ask me anything. So without a further ado, let me start my first, as I am a first speaker. So let me share my screen. So today what I am talking about is adoption of Golang in the cloud native space. So let me share my screen properly. Okay. So hope it's visible for you all. Um, okay, let me. I think I need to share the screen once again. Chrome window. Okay. Maybe I'm sharing the wrong screen. Wait a minute. So let me check my screen. I think I have not shared the screen. Okay. So okay, is it visible? My screen, is it visible to you all? Hope not. Let me share once again. Okay. Okay, now it's visible, I think. And let me make my screen bigger. Let me add a screen. Okay, now it's visible. I think now it's visible to all. And let me share a screen. So now visible. Can anybody reply in the chat? So yeah, hope now it's visible. Good. So adoption of Golang in a CNCF landscape. So CNCF is a open source non-profitable foundation built by the Linux Foundation itself now, and Go is become a very successful in this space, and in another space also. So before starting, I wanna tell my experience or why you need to go adopt to Golang without politics or adoption, just basic technical. If you see the C or C++ or any programming language, we see as a human, we write a code, we see the code, we think it's this code is need to be simple for the human and the computer. So Go is fit in the both side. Go is very simple for beginner, those who um, newbie, and maybe those who already adopted. Go is very simple to learn and expand. It has concurrency feature, lot of features there. But best part is it's easy for the machine to execute, and it's way more faster than other programming languages. uh, so let's move to. So, a little bit about me. My name is Sangam. I work at Accurics as a developer advocate, and this is a Gopher Lab. I run a multiple communities. So, this is one of a community called Gopher Lab. You can check it out. Already, I have discussed about it. So, without a further ado, let's talk about databases. So, we have the bunch of databases in cloud native space. So, if you see that there are two graduated database, TKV and Vitis. So this is a two databases which is a CNCF graduated. Was the meaning of the graduated in the sense they are widely adopted over the industry. So that's why they are graduated, and you can check there are around 53 databases out of and we will see the which databases are written in Go and what is the percentage of those database. It's just based on the code. So if you go to the CNCF landscape website, you will see this all the data. So just I have collected all the screenshot and framed over the this slide. So let's talk about TI DB. So this is a database which is open source, um, and it 100% written in Go. If you see on the screen, it's whole written in 100% Go. Another is successful Cockroach Lab is one of the very extensive, easy to scale, and robust. Cockroach DB, check it out. Cockroach DB. They have very good library in Golang if you want to integrate. Another is my favorite dgraph. If you are using, a lot of people using dgraph, amazing engineers there, and you can check a crunchy data. It's written in Go again in with 90%, 94% of code is written in Go. And another CubeDB, Norms, Pilosa, and bunch of other. And if you see here, if you see this chart, two CNCF graduated projects are written in Go. So you can say that Go is successful in the database space. Not that much, but it's growing fastly. People are creating own databases, and you can use this whole library. So you can use most of the databases integration with Go. Today we have amazing community, and they have written a lot of libraries. Uh, so let's move to the streaming and messaging. Streaming and messaging, we have cloud events, NATs, and MQ, and a lot of the streaming and messaging services. One of my favorite is Kafka. So let's move. So if you see the one of the graduated project itself written 100% in Go, and Nats is used by so many projects in today, a lot of adoption, great project, and there are only two. I think there are only two streaming and messaging services. Those are written in Go. So another is application definition and image building. This is one of my favorite. If you are building a Docker compose file, Docker images, or artifacts, this is the projects you can look for, or you can quick start a journey. And there are a lot of projects, those are written in Go. Myself, I have started contribution into open source from such a project. I will talk a little bit about in the conversation. So one of the favorite is Helm. Helm today, Helm is used by a lot of people in the industry. It's a package manager for the Kubernetes. You can just package your YML file or the Kubernetes and install anywhere. Another is build pack. Build pack is a very successful project. Now, what is the best thing about build pack is you don't need to think about the dependencies. It automatically detect and take those dependencies. You can try it out. Another operator framework. If you are using a kind of CRDs and all, so this kind of operator is helpful. Another is a Carvel. Carvel is a kind of they have a bunch of CLI. This is all tool for the developer, making developer life easy to build images and artifacts. So another is Scoop Plus. Scoop Plus is a one of a project which tell you about a cluster, little bit about cluster, what's going on in the cluster. Another dev space that we also written in Go, 79%. So dev space is a kind of, they give you a kind of a free cluster where you can go and create your whatever, spin up the your namespaces and try it out. You whatever deploy your manifest or deploy your Kubernetes application. Another is Kaniko. Kaniko is one of a tool from the Google. And you can check that is written in 93% code is written in Go, and another is Codes. So that is written in Go 68%. Uh, so Kubematrix is a another Kubernetes management tool, and now you can, that is 96% written in Go. So if you are a Go developer, you are a starter, so you can contribute to all these kind of open source projects. So another is Kudo, one of my favorite. You can write a kind of your operator or custom resources in Kudo is one of the cool project you can use. And by the way, I am not use all the project. There are a lot of project. There are 947 project in CNCF, more than that, and that is only about a CNCF. And if you see the all the on the GitHub or GitLab, there are a lot of code is written in Go, and of course that those product are not open source, so we cannot measure how many adoption happened, but you can think as what Go made an impact on the open source. On based on that you can predict things. um, so moving forward, Octant is a kind of dashboard IDE for the Kubernetes. You can take a config file, add your config cluster, and it will show the all the what happening in cluster dashboard. You can do a bunch of things. Octant is one of the cool IDE I have used. Another my favorite, Octato. So by the way, I'm wearing the same T-shirt, Octato T-shirt. So Octato is a one of a developer. They are making a developer life easy in the sense, if you are running something locally and you can synchronize those code into the Kubernetes cluster. If you are learning a Kubernetes, so Octato give you a free kind of four namespaces, I think. So you can go and try it out, deploy your things. It's a Octato Cloud. They provide a cloud solution, so you don't need to manage a whole the cluster thing. You get a namespace, you go there, deploy your things. So um, like that you can learn the Kubernetes. If anybody want any help with Octato, I'll be there to help you. Or anybody who want if anybody building something with Octato, feel free to reach out to me if you want to present. So another is a Packer is a kind of one of the tool from HashiCorp. I have not used Packer, but one of a great tool for the image building and kind of thing. So another Podman is a one alternative to the Docker Compose. You can use a Podman also. Uh, so if you are a Red Hat fan, so this is one of a product from Red Hat that is written 86% in code is written in Go. So moving forward is Porter. is one another CNC project that is their code is written 97%. And other thing, if you see here, CLI based practices. So if you are building a project, a Go project, which kind of you can build a CLI tool. So go check it out. This code. This code is fully open source to the community. So go check it out. The CLI best practices, how they are building a CLI, what they are using, and even you can contribute also, and you can start your open source journey, or maybe you will end up getting a job also. So scaffold is another tool which is similar like Octato, and it's make inner loop of a developer way faster. And there is another project Tanka. Those are written 98% code in Go. And another tool is telepresent. This is another tool you can use. This both written in Go. There are total 22 projects out of this whole thing. Out of this thing, out of 42 there are 22 projects, those are written in Go. So if you are interested into the building images, or making developer tools, creating a developer tools, so this is a perfect place. No matter maybe you are Go plus web developer, you can go and try it out. There are a lot of code written in JavaScripts and so many other technology also. So no matter you are a first year student, second year, if you know the Go, if you are beginner also, give a try. Maybe you learn something new. um, so moving forward, continuous integration and deployment. Today, if you see, Argo CD, Flagger, and Flux become a truth in the uh, GitOps world. So Argo CD is a tool which give you a kind of from direct from the Git, you can pull the resources and build your artifacts. And it's a very easy tool. It has good dashboard. So if you see bunch of CI/CD tool, you need a CI/CD pipelines to automate whole things, building your images and a lot of things. Mm. So one of Argo CD, 81% code written in Go. Flagger, it's also part of CI/CD tool. Flux, Agola, and then Breeze, BuildKit, BuildKite, Concourse, Drone, Jenkins X itself, 70%, 75%, K6. If you are testing kind of frameworks, K6 is a tool. Captain, another tool. If check it out, they have very good tutorials. If you are doing chaos engineering or something like that, so Captain is good. Uh, and there is bunch of other tools. Tecton is one of a great tool. Build top up build kit, and it's build whole. Tecton is part of CD Foundation, I think, but go and check it out. Tecton, this Spinnaker, and all the tool if you wanna. And this is one of our favorite, scheduling and orchestration. Today, Kubernetes is one of the biggest project after the Linux project, I think. And Kubernetes whole written in Go. And this is the first project who like built by Google but donated to CNCF. And Kubernetes 97% code is written Go. This is huge project, but you can try it out. There is a cool Kubernetes API with Go language. You can build your create a pods or create a cluster, everything using a Golang also. That is going to be fun project if you wanna build something, automate some Kubernetes thing. So this is a whole written in Go. Another is cross-plane from Upbound. They have kind of cool control plane. If you are using a GitOps or a Terraform, also cross-plane is. I will recommend cross-plane. Another is Docker Swarm. So Docker Swarm is when one of orchestration engine from the Docker, and you can check it out. 98% of code written in Go, Fluid, Nomad from HashiCorp, Volcano, for tool. And let's move to the coordination and service discovery. So now this etcd core DNS, this used by the so many CNC of other parent projects such as Kubernetes and all. So if you are using a Kubernetes, there is etcd which is underlying database for the taking backup and keeping all track of the resource. So there are two projects which is graduated, CNCA Core DNS and etcd. They are both graduated project. So Core DNS is 100% written in Go. etcd 96% written in Go. K8GB. So this is 93%. I have used etcd only from this. Moving to the service proxy, one of my favorite service proxy is inlet and traffic proxy. But you can see in there are two graduated, and there are a bunch of other non open source and open source. And Contour, BPE, Gbal, Inlet. This is all written in Go language. And if you wanna contribute, I will suggest Inlet is a good project. You can try it out. Fully open source, created by Alex Elise, and he is created like a lot of open source project like OpenFaz. Very helpful person. Go check it out. Inlet. Give a sponsor to this project, this totally non-profitable project. And Metal, LB, Mosh, Porter, Skipper, this whole written in Go language. Most of the code is about 60% of the code are written in Go, so you can check it out. Another my favorite, traffic proxy, 91%. If you wanna give a try, traffic proxy, reverse proxy. So they have other CNC project also. So they have created service mesh also. So give a try if you want to use. If you are using Nginx and you want to configure whole thing and update every time, but I think traffic is a good project where you don't need to check those configuration. Traffic will auto detect and do a whole thing. This is very cool and easy. And there is API gateway. There is only one project I think in API gateway written in Go is only 26%. And there are a bunch of other projects you can see. I have not used this project, but you can see the code. 99% code is written in Go. Moving to the service proxy. So service proxy is kind of a mm, mesh engine to like deploy your Kubernetes, manage microservice applications. So Linkerd is one of the incubated project. You can check it out. There is a cool program from the Linkerd. It's called Linkerd Hero. You can contribute and become a Linkerd hero. There is STO. There is one of a mystery. Mystery is one of a cool community. You can go and check it out. Mystery, there are a lot of students, those who contributing the website and contributing the different way. So you can give a try. Mystery is one of a cool. If you want to begin a contribution into service mesh or want to understand, Mystery is one of a good community, and go and check it out. Open service mesh from the Microsoft. You can check it out. That there is another mesh is traffic mesh from the traffic lab. You can check it out. So this whole project written in Go language, you can see guys. So moving forward to the cloud native storage, my favorite cloud native storage is OpenEBS, created by Data. And there is a bunch of other, you can see other CNC cloud native storage solutions. So this is whole written in Go. And you can, I will suggest Minio is one of a thing you can go and check it out and start your, like, you want to understand storage and everything how it's work. This is written 100%. And there is another foundation, new foundation called Soda Foundation. Go and check it out. They also have kind of good uh, project there. um, and moving forward to the container runtime. So underlying technology of Docker is container D, and you can now with Kubernetes use deploy your, you don't need to depend on the Docker itself, so you can use cryo or container D. And there is a bunch of other uh, container runtime solutions. So container D is totally written in Go. Cryo written in Go, gvisor, Kata containers, LXT, opens container initiative run C, singularity, and this all written in Go. If you wanna contribute to the how to build this how to, if you want check the how runtime works, and this is very uh, deep projects, but you can give a try. You can at least deploy your Kubernetes cluster using cryo or container D images rather than using a Docker. So moving to cloud native network, this is one of the favorite space for the any Golang developer. There is, you see the most of the tool is written in Go here. CNI network, cloud native network interface. This is written in 98% written in Go. Another is Anteria, and bunch of other things. One of my favorite is Funnel, which is written in Go. More 93% code is written in Go. Check it out, Funnel, and you can check other Kube router is good project, and Wave next net is good, and Submariner also good. So I will say Wave, Submariner, and Kube router Funnel is good to start or learn about network, cloud native network. And moving forward, automation and configuration. And most of the people I know they use Terraform, and there is bunch of other things like Ansible, Chef, Pulumi, great projects, automation. So if you see most of the project written in Go, Cubase is incubated project, CNC incubated project. In the sense, a lot of people adopted those. So Juju also good from the creator of, it's created by I think Ubuntu. So they have automation and configuration tool called Juju. And another my favorite is Linux Kit. If you know the movie project from the Docker, so they have something called Linux Kit. Go and try it out. Very cool project. Um, and another now current my favorite is Pulumi. You can write your whole infrastructure in Go using a Pulumi. They have a bunch of great libraries. You can try it out. And another two great projects, Tinkerbell and Terraform. So Terraform is now version 1.0 is released. Terraform is widely adopted across the industry, and this has become one of a cool, one of the de facto standard infrastructure as a code. You can write a kind of whole infrastructure in the code and deploy, maybe that is AWS or on-prime, GCP or anything. Container registry. So container registry has become one of storing your whole the registries and whole thing. So there is a different cloud provider provide a different registry. There are two project, one is incubated and one is graduated. Harbor is registry. Portus is good. You can check it out. Portus and other artifact storage solutions. So from that, this whole registry, container registries, written in Go. So you can automate this registry with Go. They have rich Go APIs. Moving to the favorite part and favorite part in the CNCF and Buzzy is security and compliances. So there are two graduated and two incubated projects. One is CNCF graduated project with OPA, widely used. We also use at Accurics. And another is TUF, another is Falco, Notary. If you are using like Docker, so Docker use Notary. So there are a bunch of other projects, and at Accurics we have our own project in the CNCF called TerraScan, which is scan infrastructure as a code before the provisioning infrastructure. You can check all the violation, what happening, and what's going on in the your infrastructure as a code. Check the security before deploying itself, so it will reduce the risk. So this is great tool if anybody want to learn TerraScan, or anybody want to contribute to it. Reach out to the any reach out to me if you wanna write a blog, talk about it, wanna learn, give a try. Let me know. So moving forward, OPA is a open policy agent. So they have something language, one of a language called Rego programming language. So you can write the policies into those. Uh, so OPA works. You can connect this OPA technology with any CNCA project, maybe that databases or anything. So you can check it out. Those things. Another is Notary, Cert Manager. If you are doing a certificate manager for the Kubernetes, Cert Manager, one of a project where you can use it will do all the automatic work. So there is bunch of other projects and which those are fully written in Go, and Terras can also written in Go. If you want to contribute, let me know. And moving forward, key management. So key management become very kind of important in the CNCF space because we store our environment variables, where key values, how we storing is those are secure. So this is whole tools written in Go language. And another one of my favorite tool here is Vault and Teleport. Teleport is a tool where you can connect your Kubernetes cluster databases remotely and remotely access. Let's see, you have two developer using one cluster, so you can give one kind of node, worker node or something. You can give access via the browser itself. So this is a great tool. Check it out, Teleport, guys. HashiCorp Vault is a key value. This is like key management tool. Vault is used widely across the industry. Okay, thanks. I think this is like kind of a boring session. There is so many project, and I'm always like talking but there are other programming language. Do learn whichever make your life easy or want to learn. Yeah. So this little bit overview around adoption in CNC. So you can start learning Go and contribute to the open source or build a cool project. So next we have one of engineer from Accurics itself. So he created one of a project called one of a programming language in Go called Mutant. So let me over to you, Gaurav. So let me stop my screen. I'm adding you here. Hey, hey, Gaurav.
Hello. Hi, Sangam. Am I audible?
Yeah, you're audible. Can you share a screen?
Yes.
Yeah. First of all, thank you for um, this presentation. I'm really looking forward to learn more about Mutant and your experience around creating uh, this programming language. Now, of course, it's open source; anybody can contribute. And Gaurav did a really great job of creating such a language. Uh, he built a great documentation around it, so you can go and check it out. A documentation also he will share. Over to you. Can you share the screen?
Yes. Thank you, Sangam. Give me a second. I might have to rejoin. I need to give my.
Yeah, no issue. No issue. Rejoin. So anybody has any kind of questions, feel free to the ask in the comment section or join a Discord. Um, so Gaurav will join in 5 minutes. So let me introduce another speaker while we have a time. So we have one of our speaker from the Facebook itself. So this is like recorded, not because of time zone. So let me one of a great project from the Facebook open source. Facebook has bunch of different open source project also. So we have one of a speaker from Facebook. He's a developer advocate for open source Facebook. After the Gaurav, he will present his demo. So let me add a Gaurav. Hey, welcome back.
Hello, Sangam. Thank you for having me here. Thank you for this great platform and this opportunity. It's really great to be here, and I would love to share about my programming language that's Mutant. About my introduction, I believe Sangam has already told you what do I do, who am I. So let's just skip that part and move on to the presentation.
Yeah.
So,
Let me add
Sangam has
your.
already shared a bunch of really cool projects that have been written in Go, right? And how cool this programming language is. It's really simple. It's really easy to use, garbage collected, cross-platform, and everything that you can dream of. So, it's as easy as Python and as fast as Java, even more faster than Java in some cases. Concurrency is super easy. So now I'm here to talk about what you can build using Go. What more challenges that you can take on. One of the things that you can build using Go is another programming language on top of it, right? So that's just what I did. I really wanted to experiment with it, so I created Mutant programming language. Now the whole idea behind this programming language is that it's a secure by default programming language. At times when we have to write commercial products, when we have to write some product that should not be pirated, like computer games or some movie streaming desktop application, or some application like that hosts some proprietary content. You want to make sure that your product that the product you are selling, it does not get pirated. Yes. And a lot of times the companies go to a lot of length. They go the extra mile of writing assembly code by hand so that their code changes on runtime. So that's metamorphic code, and sometimes it's polymorphic code. In polymorphic code it changes just a little bit. In metamorphic code the entire logic changes on the runtime every time. But it's very difficult for it and work, and you have to hire very experienced, uh, very extremely good developers. And when you do hire them, a lot of their time is spent working on the security side of things. I believe that the security should come by default. It should be like a fundamental and default feature of every programming language. It's not something that we should worry about over time. We should not be spending too much time, working on security ourselves. It's something that should come by default. We should be building our product. We should be working on the business logic side of things. We should be shipping out features because that's what the customers want, right? The customers would rarely care about the security updates, but if you refresh the user interface or if you provide them some cool new features, then that's something that will provide them more value. Security is usually invisible, which is why Mutant is here to encrypt your code by default and add a layer of security. How is it going to do that? Let's see in other slides. So before we get into it, let's see some of the features that this language has. It has garbage collection, Unicode support, cross compilation, automatic constant obfuscation, compile time encryption, and runtime encryption. What does it all mean? It's just buzzwords, right? So let's just get into it. So when I say garbage collection, I'm just essentially piggybacking on Golang's garbage collection thing. I have not implemented it myself. I'm not reinventing the wheel here. So Mutant programming language does garbage collection by simply using Golang's garbage collection feature. It works really well. There was no reason to change anything. So it came as an automatic feature into the Mutant programming language. Moving on to Unicode support. Now, this we have languages other than English, right? So we have characters that are non-ASCII, like Hindi, Japanese, Korean, Russian, etc., and some other symbols that are not defined by ASCII. Now, these symbols are supported by Mutant, and they're also supported by Golang. So naturally, I had to do make some changes, and instead of simply using characters or bytes, I use the runes feature of Go to enable Unicode support within Mutant programming language. One of the future features of Mutant programming languages would be writing code in Hindi or Gujarati or Korean or some other non-ASCII programming language, because not everybody knows English. So that would be an upcoming feature of Mutant programming language. You could essentially write the code, the syntax, the keywords of the Mutant code within a different spoken language, whatever you like. So stay tuned for that, and hopefully we'll be adding these features very soon. Moving on to cross compilation, Mutant has a release build feature and a debug build feature. The debug build feature will work on every platform as long as you have Mutant virtual machine installed there. But the release build feature is where the cross compilation really works. You can build a release binary that will work on Windows, Linux, macOS, and Android without installing Mutant or Go or any other language there. It will compile a standalone single independent binary just like Go. Now, about automatic constant obfuscation, it's a bit of a mouthful, right? So the idea behind automatic constant obfuscation is that whatever content that you're writing there, whatever variables that you're using, be it some string variable, be it some value in integers or some boolean, then all that data will be encrypted at the compile time and the runtime level, so that they will be essentially obfuscated. And even if you try to reverse engineer it, it will be very difficult to get the values of those variables, because they're all encrypted. They are all encrypted down to the runtime level. And we'll see everything when I show you a demo about of how all these things work. So about compile time encryption, the bytecode that I'm emitting, all of that bytecode is encrypted, and it's before it's written to the file. So that's just compile time encryption, right? It's just an AES GCM seal encryption, and the nonce changes every time. So even if you use the exact same code and compile it 2 times, the encrypted code or the encrypted bytecode, the resultant code is not going to be the same. It's going to be different every time because the nonce changes every time. So that's an added layer of security there. About runtime encryption, whatever instructions that we are adding, there's an add instruction, print instruction, or some other instruction. So down to the instruction level, everything is encrypted one by one. And it's all you can see in the source code. You can see what encryption algorithm have used for that. And these individual instructions, these individual components are decrypted only when they are in use. So when I am printing something, or when I'm performing the specific action of maybe adding two variables or maybe some other logical comparison, only at that point one will be able to see at what is going on, what's the state of those specific variables, what's the instruction itself, what data those instructions contain, and what kind of operation is going on. They won't be able to see the state of the past or the state of the future. So it would be very difficult for someone to reverse engineer and construct a control flow, a graph of the entire workflow of the program, that what's going on in the program, what's going on in the process. It will be very difficult for automated tools like EDRs and antiviruses that scan the memory. They won't know what's going on. They won't be able to read it, right? Because it's all encrypted. It gets encrypted only and only when that specific instruction is in use. Now, about Mutant Virtual Machine, it's a simple stack-based virtual machine. It's designed after Java Virtual Machine. So it sort of works like Java Virtual Machine, the way it does. Now we have multiple types of virtual machines. Right? We have infinite register virtual machine. We have stack-based virtual machine, and we have some other. And there are some other ways we can do this. Mutant uses a stack-based virtual machine, so everything goes on top of a stack, all the instructions go there, and then they're popped whenever they're used. And if whenever a new instruction comes, it is pushed back on the stack again. This virtual machine ensures cross compilation, cross compatibility, and it helps in working the programming language on multiple operating systems. So you can write your code on Android, Mac, Windows, Linux, wherever you want to write, and it will work there. In some cases, it might even work on ARM builds like say Raspberry Pi or other IoT boards. However, that has not been tested. It's something up to you. Maybe you can test something. Maybe you can contribute back to the GitHub repository of Mutant language. It's because it's an open source research. You can always contribute to it. And of course, the security aspect of it is not perfect. Maybe you'll be able to find some vulnerabilities. Maybe you can find some loophole where I'm leaking some data, or maybe you have another layer of security to add to it to essentially stop or make the life of reverse engineers really difficult and make our product secure, a clean package that cannot penetrate it. So now let's move on to the more exciting part. That's demo, and I'll write some code. I'll show you how things work. Before I write some code, allow me to show you the REPL, the read eval print loop, and it looks something like this. Right. So first, it will greet you that hello Gaurav, welcome to Mutant programming language, and we can get started here. So we can print find a variable here. Let name equals to something.
Can you make little bit like bigger font size?
Okay, let me see how do I.
Control plus or command plus if you're using Mac. Yeah, a little bit. Yeah, that's good. Yeah, perfect.
Okay, I
Thank
hope
you.
it's more visible now.
Yeah, it's visible. Thank you.
Okay. Thank you. Right, and we can print out this variable using puts, and it works. Right, and we can add a few things here and there. It's all right? I mean, we cannot really see the inner workings, but that's okay. We're going to write some code in the file, and then we're going to compile that file. All the mutant code is written in a file that has an extension of mut. So the source code will be picked up from mut file. And let's make a very simple program that checks for a password. And we can define a function, check password. This little function is going to check whether the password or the value of the password is Apple or not. And we'll take this password as a user input. Enter secret word, and hopefully things will work. You have to tell Mutant language what kind of data type are you accepting from the user. Is it a string? Is it a number? Is it something else? Semicolons are not compulsory, but it's recommended that you use them. Otherwise, there's some unintentional behavior from the programming language. It's currently being worked upon right now. So if the password matches, you can say something like, okay, you win, or door is open. Otherwise, and go inside. You see what I did there? Can't go inside. Go. Okay. Anyway, now let's just compile this little file. To compile our source code, we use mutant space the file and the name of that file, and it's going to compile into testfile.mu. Now, how does this compile file look like? This is how it looks like. It looks all gibberish, right? I'll explain how what's going on here. MUT and ANT are the header and the footer of this file. This is how Mutant identifies that a certain file is a compiled file or not. This is the file signature, so it's easy to identify that a certain file has been compiled using the Mutant compiler. Other than that, this is your entire bytecode. This is the source code that has been converted into a bytecode, and it has been encrypted now. And this is the shadow 256 sum of this entire bytecode. So if you make any changes, it will not match, and it's not going to work, right? But first, let's see if it's working or not. And to run this file, we need Mutant, because this is a debug file. This is not a release build that we have created here. This is just a normal debug build. So that's why it didn't take much time to compile. Let's see what's the secret word. I don't know the secret word. The secret word is XYZ. Can't go inside. It didn't work. Okay. Let's see. Maybe I know the secret word. Maybe it's Apple. Oh, wait, it's working now. Right. And now we're going to compile a release build. Use mutant release, and we give it a source file. And I want to compile it for Windows. So I want to give it operating system Windows. It's going to take some time to build it. Maybe a few seconds. Okay, it's done. Didn't take very long. And let's see, do we have a file here? Yes, we do. Is it really a Windows build? Let's verify that. And it is indeed a PA32 executable that is a Windows executable. But I'm still a little bit skeptical. I don't know if it's really a Windows file or not. Maybe it's not working. Maybe I'm lying to you guys. Okay, so let's just take this file to a Windows virtual machine and see if it's working there or not. Okay, we have a Windows virtual machine right here, and we have mutant test folder here where we are working. And let's just take this file to a virtual machine and we copy it like this. Easy. We open our command prompt and check whether the file is working or not. Okay, testfile.exe, and it is working. So Apple, and Apple works. The door is open. And just to verify, Mutant is not installed here. Right? Mutant programming language is not installed. I hope it's visible. Or is it? Okay, I accidentally opened this. Magnify. I wanted to increase the font size. Right. If someone could help me with the font size thing, how do I increase the font size in command prompt? Right. Maybe I can use
Yeah,
this.
from here also, or you can press command plus plus, it will work. Yeah.
Okay. Great.
Yep.
So let's start again. So we're here, and That doesn't work. Right. Test file.exe is right here, and we can run this file. If I write if I write incorrect password, it's not going to work. But if I use the correct password, it works. We don't have Mutant installed here. It's a compile file. It's an independent compile file. So we do not need Mutant or any other thing to be installed here. Now we can let's see if we can compile it for a Linux machine. And yes, we can. Let's see if it's compiled or not. Yes, it is. Here, this is the file. It's compiled for Linux. It's a 64-bit binary, but we can also compile a 32-bit binary. Let's see how we can do that. We give it 386 value for Arch, or we can use x86, whatever works for you. And see, now we have a 32-bit compile file. But does this file really work? Let's see. We also have a Linux virtual machine somewhere around here. And here we go. And we have restored the state. Okay. I guess it takes a second. Let me see. Yes, we can copy this file here, and we can open our terminal somewhere around here. It's in desktop, Mutant test. Okay, file is here. It is a compiled file, as we have already checked that. What else can we do? Let me just try to increase the font size here as well. Okay, that should take care of the font size. Let's try opening terminal again. Okay, great, font size is bigger now. File is here, but first we need to check for permissions. Okay, maybe we can execute this here after all. And it works. Test is not the correct password. Correct password is Apple. But you might ask, this password is hard coded. Anyone can see it, right? We just need to use strings. But that's not true, because the password is obfuscated and that all the instructions are encrypted. And I'll show you. Just see garbage here, or we can redirect the output to something else. And open our VS Code here to see what's going on. Okay, test strings. Let's try and find Apple or something else here. It's not here. It's like append and something else. It's something related to Go maybe. Case in point, our password is not here. It won't be there because the entire bytecode is encrypted. So that's all. We're done with the demo. And if you have any specific questions, I'll be happy to answer.
Hey, great demo. I really like the concept of encrypting the whole thing in the programming itself. Really a new concept for me, but really great project. And this is a just I think you have released first version or not yet?
This is the second version. This is the second.
Okay, Okay, this is a
Yes.
second version. This is just a beginning of the project. But if you see this compile, you can cross compile over the different thing. Now where this project, if you ask me where this project fit in the CNCF, if I want to use something like this in the bigger picture, let's see a key management. You have seen a lot of key management things. If you anybody adopt the Mutant and you add this whole thing in your pipeline or somewhere to secure your thing, secure your platform, so this is good example of programming language. It has multiple feature. It uh, support lot of things. A really great work and hard work, Gaurav. Really appreciated your work here. Uh, and this is just a beginning of the project. I'm going to contribute definitely. I recommend everyone to. So we have one question from the audience, Gaurav. So
Yes, sure.
on the screen, how Mutant encrypts the code? If you tell a little bit, this is a question for Atar Patil. Uh, and another question is Mutant slow or faster than Go? This is something different kind of question. Uh,
Okay, great. So I'll start with the first question.
yep.
Yeah. Individual instructions are encrypted using XOR. I'm not using very heavy encryption or very heavy algorithm
Hmm.
for those specific individual instructions. Because
Hmm.
down to the instruction level, if I use very heavy algorithm like say AES or DES or something else, then that's going to take a lot of time. There will be a lot of instructions, right? So that part is encrypted using just simply XORing in the instruction with the key. About the when all of those instructions are encrypted and they are compiled, then the entire bytecode, that is the compiled bytecode, is received. We then send it through another encryptor that's going to use AEC GCM seal method. So it's sorry, AES GCM method, right? So AES GCM is one of is a very secure encryption methods, and it uses nonce. So it's a pretty cool thing. You can read about it. It's all open source and everything. So that's how it works. About the second question, it is slower than Go, right? It is built on top of Go. It's sort
Go.
of an abstraction layer on top of Go. So it will
But Go
probably,
itself a faster. I believe Go itself a
yes.
faster. So you have seen the demo. So I can say Mutant is faster. Because it's depend on Go language, and Go has minimal dependencies, not like other programming language. You can compile within a second. It's I will say Go is like advanced C programming, so this is much faster, and I think I think Mutant is fit for the security purpose. We are not here to go or slow or fast, but this is great project. Uh, can you share the so this is a Mutant repo. Can you walk us through the repo, or maybe documentation? Anybody want to contribute into documentation, or anybody any kind of open source contribution or repo contribution?
Yes, sure. So this is the mutant repository. You can find it here. This is the URL github.com/Gaurav-Gogia/mutant. So this is the repository here. You can contribute here to some code. Maybe you can add more documentation. For the documentation part, there's a separate repository. There's a separate website. I'll share that link as well. So let me just share this link right here.
Yeah. You need. I think private chat you can share. I will share with the audience. Yeah. So I'll be sharing this link in the comment section. So
All the document. Yeah.
go check it out. All the document is open source, and he built a kind of documentation website also, I think. Uh,
Yes.
yeah. So this is a website, really great feature. Now if you are a beginner also, this is just early release of if you want to improve the documentation, fine. go contribute. Really great how to install data type, just like another programming languages. And one of the fun part is Gaurav is here to help you out. You can directly learn from the creator itself. Or ask or give an idea. So anybody want to collaborate, a really great project. Thank you, Gaurav, for sharing a wonderful demo. I really enjoyed, and I will give some of the my suggestions also about the project and maybe some idea we will discuss maybe after this event, or maybe some hangout session we will arrange for you. Thank you very much. I really appreciate it. Go give a start to this Mutant project, and share across social media if anybody want contribute. Thank you, Gaurav. So moving forward to the our next speaker. So next we have a speaker from Facebook itself. So let me share a screen. Here we go. Let me maybe let me share. Let me share. Okay. Give me 1 second. Just I'm finding there are so many. Okay, here we go.
name is Dmitry Vinik, and I'm a developer advocate on Facebook open source team. Today we'll talk about a project Ant and how it can make it easier for you to deal with data when working with Go programming language. So let's go. As I said, today I'll talk about Ant and how it can make it easier for you to deal with data in Go programming language. But before I do that, I'd like to introduce myself a bit more. And so what do I do? As I said, I'm an open source developer advocate, and we are dealing with a massive portfolio of open source projects, more than 600 of them, and there are different pillars and areas of focus. And for myself personally, I focus on mobile development, Android, iOS, and hybrid open source projects like React Native, Litho for Android, Fresco for image management in Android, but also Flipper, which is extendable mobile app debugger, and many more projects. But more importantly is that I'm very passionate about open source, and that's why I'm talking about Ant. And what is Ant? Ant was originally open sourced by Facebook, and it's ORM for Go programming language. What is ORM, you ask? ORM is Object Relational Mapping. And again, it's a term, it's an acronym, and to define it, I would use the most best online source ever. It's a technique for converting data between incompatible type systems using object-oriented programming languages. It's a long sentence by, as I said, the best source on the web, Wikipedia. But ultimately, in simple terms, what it does is, imagine you have an entity, user, in your code with a certain number of attributes, user ID, first name, last name, and then you have a table in your database with the user ID, first name, and last name. That basically map to your object. In between, you would have ORM that will connect your objects in your object-oriented language, which might be Go or Java, with the table. And you don't have to call particular transactions, deal with constraints. It will be handled for you in the ORM of your choice. And this ORM is what we're discussing today with Ant. Ant basically is that object relational mapping that we can use for Go. And why is ORM important? Because why would we even discuss it if it wasn't? It's all about data. Everything is about data. Big or small, most applications are data driven. An example is, for instance, Google Cloud integration, this simple diagram. It's really driven by data. It has an important piece of the entire pipeline. If you talk about AWS, the startup use case that they have on their website, it's also all about data. They're dealing with data. And an example, of course, as I'm working at Facebook Scribe, the log processor, there alone, we're dealing with a massive amount of data. In this case, logs, which is again a data. Data is extremely important, as we just highlighted. Then ORM is important too. If you're dealing with something essential, whatever you using as a tool for that data is important. And I've kind of talked about already theory quite a bit, and I personally do not like theory too much. That's why let's look at the code. Let's look at Ant in action why it's so powerful. Again, they have great documentation that you can find on their website. And if you were to go to the simple intro page, you would find that the only thing you have to do is you have to run go get and go to get the CLI installed. Then you initialize your project. In my case, I call it and go talk. And it will produce you something like this. As you can see here, I have just a simple file for the project with a module name. Then if you run another operation to initialize simplest entity, simple file, user in this case, because you remember that's like the easiest use case I can think of. And again, you can see that on a website as well. It will generate a schema for you, for the user, with fields, just the placeholders initially. But if you wanted to take it further and let's say add age, name, or whatever else you might decide to add, those fields, after adding them, you will run generate operation with and it will generate all sorts of files that are necessary for you to use it. It's already fully functioning, so you can deploy it and start working with and right away. If you wanted to create entities, for example, you create a client. In the client, in this case, I connect to SQLite 3. And if I wanted to, as I said, create a user, the only thing I have to do is add this operation that sets name, age, or whatever other attributes are required for my entity. In the situation the way I showed before, I had first name and last name. Here I just have age and name. It doesn't matter. It's just all about showing you how simple and quick it is to have something in your code that will allow you to interact with data as any other ORM will allow you. And again, it's just a simple insight on how simple it is to start. And if you were to obviously not just create but read something, querying the entities, again, you will add a query user function. In that function, you choose by what you're gonna search for. It can be an ID, it can be a name. In this case, you can see that I just call a query function and specify a where clause. Similarly, as you were to do a query in the database directly, but here you can do it in the code. And that's the only thing you really have to use. And again, if you want to go deeper, you'll find it on their website on andgo.io. And there's a lot more. If anything, Ant has a great deal of documentation you can pick and choose from and get started. There are many tutorials in there already. It teaches you how to set it up, more than just intro, just step by step. It goes into more complex situations, how to create a to-do, how to query and mutate your data. And more importantly, if you wanted to have some integrations, let's say with GraphQL or Relay, it also goes into those details too. And of course, there are more docs than that, right? There is the more complex documentation about schemas, about migration from the databases, how do you do graph traversal, and a lot more than that. And of course, I'm really glad they have that here. It's about testing. No production code should be left untested, I believe. I'm not talking about 100% coverage, but you should have some tests to make sure something as important as dealing with data is tested. And fortunately, this project has that right in the documentation on the main page. If you are, you really want to see the internals, you can go to the Go docs that's available right on the website, and it has all the information you need for that. But really, it's all about the community. You want to join the community, don't just consume a project like this. And the community is great. It's growing right now. They have a newsletter, the blog where they try to connect with the audience and discuss what the new features might be. They have a Twitter account if you are following Twitter for the most part. And of course, they have Slack to discuss and do the Q&As whenever necessary. Or if you have a question about starting to use Go. And I always like to end my talks with quick call to action that gets you going after the presentation is over. I know it was a quick one, but I hope that you will experiment with tools. I haven't showed you much here, obviously. I just show you how to get started and why ORM is important if you're not using one. But if you are directly dealing with data, you would find a great project to deal with, a great tool to add to your toolkit. Join the Ant community. Don't just use it. More importantly, try to contribute back. That's the very nature of open source. You join the community, you become a user, then you become a contributor, and then you might become a maintainer. Just try to engage and contribute back. Don't just consume. And with that, I'd like to say thank you. Follow me on Twitter, go to my blog, LinkedIn, or email me directly for any questions. And thank you so much for listening. Goodbye.
That is a great presentation from the Dimitri Vinick from the he work at Facebook open source. Check it out. There are a bunch of other open source project from the Facebook open source program. You can contribute, become a contributor also. So there are a lot of open source project, and whenever you see the open source project, don't consume them. Try to contribute back, use it, make a developer life easy, or those who are building this such a tool. Dimitri built a lot of great material around developer advocacy and how to contribute to community and lot of things. Go check it out. Follow on Twitter. Reach out. Very helpful person. Moving to the next one, we have next speaker from who created a Go cache system. You can for the traffic. We already discussed a little bit about traffic, which is a reverse proxy. So let me share a screen quickly. So here we go.
To the organizers team to let me talk to you about my side project Reader in Go, and obviously thanks to all of you who are listening me. Before diving into the subject, let me introduce myself and make my self-promotion to you. My name is Sylvain Combraque. I'm from Lille in France. Then sorry for my baguette accent, but I'll try my best to speak as well as possible. I'm traffic contributor. I'm also creator of the cache system we will talk about, and you can find me on GitHub searching Dark Week and Dark Week Dev for Twitter. So let's replace the context of why I started to dev using Golang and how I came to do it. As I said, I'm traffic user since the version 1.4. I'm contributor and helper, and for those who doesn't know traffic solution yet, it's a reverse proxy created to manage container architectures, and it's a container first approach. It supports the hot detection deployment, the scaling. It load balances your request automatically using the waiting round robin method, and use only a specific port for all services and all protocols. Traffic manage for you the service resolution depending host in entry. Then it's a pivot point of your infrastructure. It's like Kong or Nginx for those who have already worked with them, but really simpler to configure and to set up. Another good point is the fact you can install it on your development environment and continue your work instead of bigger reverse proxy. Then, as you can hear me, I love to use traffic, but after months to use this solution, there was an issue I was facing too. There wasn't any cache system internally to traffic. Then all requests would have to resolve the associated service. Then it took many milliseconds to be done. I searched after a cache system solution, but nothing appeared to be as efficient as I wanted, or it was only POC. And after many nights spent to look after that, I decided to create my first program in Go. And the fact I was totally noob with this language, but it didn't scare me because I had a goal, and for every kind of project, when you have a goal, you'll do your possible to achieve that as any possible ways. And it's different to start a language with a goal and learn a language through a tutorial. You're more implicated in your development, and that's how I came to learn Golang, with all of its dark sides and obviously all of its light sides. So this project called Swan is actually in version 1.5.2, and for the record, the release names are free beer names, because I love to drink beers. And obviously don't forget to leave a star, because I've got an oversized ego and it makes me happy to view the stargazers count growing. So first let me show you how Swan is versus Varnish. and obviously just a tool. I love the Varnish developer team, but we are in concurrency to serve a cache system solution. And I think a demo is better than words, so let me show you how to set up Swan with a minimal configuration. I prepared a little video to show you. Let's see together what's in the Docker Compose YAML file for this project. We are declaring some services, traffic, that's the reverse proxy, who am I, which is a container that will give us some information about the container that handles the request, and it will print the headers and will respond to the domain.com CIDR. After that, we declare the Swan service. It will be placed before the reverse proxy, and it will handle all incoming requests. And we map the Swan configuration YAML file to the path configuration / configuration.yaml. And the configuration file looks like this. As you can see, there is no tricky parts in the minimal configuration. We declare the port to listen in the default cache port key, and we tell to cache to the cache system to cache the response for 10 seconds. And as its time declaration, it could be 10M for 10 minutes, for example. And after this, we will launch the containers. The very first call will take around 27 milliseconds to be done, and that's traffic warm-up and traffic launching. So it's normal to be a little bit higher than the normal. And the real first call will be around 14 milliseconds after the first warm-up from traffic. And once the response is cached, Swan will respond under 3 milliseconds. And that is that I was recording, so performances were lower than the production mode. And as you could see, there was cached status and edge headers in the response when it's served by Swan. So after the demo, let's dive together in the theory of how to build fast applications using Go and what were the complicated parts. First, I can't talk about Golang features without mentioning the GoRoutine feature. If you don't know that, a GoRoutine is basically a part of a thread. It's a logical thread, and which will run one task, one function detached from the main thread, and will close if the main thread stops or if it reached to the end of the function. In this example, we can see that a cost function will be dedicated to another thread to be more efficient, and because we don't need the result of this execution. Then here the update cache eventually is really cost effective due to headers validation, RFC checks, etc. And you can easily do concurrency with a Go keyword placed before the function declaration and before the function usage. Then another big feature is the channels. We can wait in the main thread for informations or push data to the Go routine. Today, a real Golang application without channels and obviously Go routines doesn't exist, or it's really, really rare. A channel is like a bridge between the main thread and more precisely the thread that instantiated the channel and the associated Go routines. For example, I used channels to thread the incoming request and be able to coalesce them if needed, and only when the response is available, I return it to the client. With that, I can manage multiple connections at the same time on different or same endpoints, and as a channel, as a type, we can define our own channels. Like here, we are defining a reverse response channel that can take the same type as input and output, and you can only pass and retrieve some reverse proxy type or reverse response type or nil. So I don't know why. If someone have an answer to that, sometimes it's better to close manually the channel, like in the line at line 19 and at line 26. But sometimes it's better to let go close the channels by itself. So I don't know why. I can't explain that. So if someone have an answer, it would be cool to share with us. So I was facing another issue while I'm developing using Golang. That Go doesn't support generic types at the moment. But in the second version of Go, it should be okay. So we have to wait, and we have to find some tricks to be able to pass as generic generic object as possible. And the solution is to apply the dependency inversion principle to decoupling software modules. Thanks to Wikipedia for this definition. So basically, it's using interface instead of the implementation. So it's simpler. So it's a little bit tricky in Go to implement an interface, and sometimes you can implement an interface under the hood without knowing you're implementing it because you don't have the implement keyword in Go, and so sometimes you don't know you're implementing an interface. For example, in Swan we have some providers to be able to let the user decide which kind of storage system should be used depending the matched URL in the full version. And here we are defining the type of each provider. Each provider defines same functions like list keys, get, set, delete, and many other functions. Some these functions have the same signature. So to make a generic object, we can define an interface like the abstract provider interface, for example, which will contain the method signatures, and each structure defining all the function with the same signatures will considered as implementing the interface and can be part of an abstract provider array for abstract provider interface array, for example. So after that, we can pass our Redis or our Badger provider, and as the two structures are implementing the interface, it won't crash, but your IDE you'll have the auto completion for an abstract provider interface object and not your real object implementation. So what are the cool features in Swan? The first one is the YAML configuration. which is simpler than the disgusting VCL for varnish configuration language. Here you just have to define a YAML and it works like a charm. So on the left you can find the minimal configuration and I'm missing something. To be able to run a Swan instance, and on the other side you have the full version, the full configuration for the full version containing Redis provider, etc. Then as it's YAML, you can use anchors. You can write scripts to create dynamically the configuration, and the most of all, the configuration supports the hot reload. Then you don't have to restart Swan if you change the configuration. But I plan to disable this feature by default in the future to avoid a memory leak, and because it makes side go routing running to listen the file changes and reload configuration when file is saved, and it's cost effective. So keep in mind that existing keys are always stored and available in your providers and will be purged only when the TTL reaches 0, or if you decide to purge the cache by reject or URL or tag directly using the API, but we'll talk about it later. So as traffic, Swan is container first designed to be compatible with as much as possible with existing systems. You can define a docker compose.yaml file for Swan, exposing the needed ports, and map the configuration file path, and be sure the reverse proxy is in the same network as Swan instance to avoid the external requests. This is the configuration for working with Swan out of the box. There is an available KDE module and a traffic module, traffic plugin, which will be released when they support plugins that use the unsafe library. So I hope this day will arrive soon, but it's like it's around 1 year. I'm waiting for that, so it takes time. So it supports the request coalescing system support. Thanks to Single Flight for providing it, and it let me save around two days of coding. So using a library can avoid the maintenance of the base code, and Single Flight provides some cool stuff for this. So it supports the HTTP cache status header. What is the cache status header? It's the new RFC property. Previously it was X from cache, and here you can tell the cache is served by your provider, here Swan, and you tell if the cache were hit, miss, passed, or any other things, and that the RFC compliancy, and it supports the edge header that tells the user, okay, your cache is 5 seconds old actually in this example, so the user can know the age of the cache. It has an API management. Here you can find the configuration to configure the API. By default, the bus path for the API is Swan API. You have the security API and the Swan API. All APIs will be placed after the BasePass Swan API or any other base endpoints depending what you configure in the configuration file. For the Swan API, you're able to list the stored keys in the cache, and you can purge the cache using an ID, so the cache key directly, or regex, or you can purge using the tag, the YKey tag, like varnish, since the 1.5. So you've got many ways to invalidate the cache, and by default is placed under Swan path. So if you let the base configuration, Swan API will be under /Swan API /Swan, and that's it. So as we don't want to let the user be able to invalidate cache, I implemented an authentication API to be able to log in and receive JWT, and be able to invalidate cache and request the cache keys in the backend. So you have by default the path authentication, and you have two routes. The first one is to log in. You send a JSON request with a username and password, and in the response you have a set cookie named Swan authorization token containing the JWT, and you have a refresh endpoint to refresh your JWT. So how to code this? You have to tell if you fill the main bus path, it will take the value. If the bus path is empty, it will take Swan API, and after that I make a loop over the enabled APIs, and for every endpoints I'm declaring an HTTP handler to handle the path with and without the trailing slash, and I'm executing the handle request method as which is an HTTP handler. So to finish with that, Swan is compatible with many softwares. It's compatible with PrestaShop, WordPress, and you can manage your Swan instance using the administration panel with Apache, Nginx. In the future, it will be compatible as the official way with KDE and with TIC. This solution is an APM management, and it will be integrated with that. I need few weeks to fix some things, and it will be okay. So after that, in the next big release, all these softwares will be compatible with Swan and solution will be maintained to be able to implementing it in this solution. So that was the funny part, and I was facing the most complex part. After that, the first one was the real problem. It was the RFC implementation. Support RFC rule is really good to face and fight the depression, because you think you're done with that, but another rule comes and you have to rewrite parts of your code. The RFC for request for comments designs the semantics of the web and apps to homogenize and define standards of your responses, your behavior, and don't let the creator of the system be free about the implementation, logical part, and data processing. Here is an example with the RFC 7234. This is a single page, the first page, and there are 42 other pages, and that was a pain to support that, but thanks to other developers that implemented it in the past, then I can take advantage of their existing work. Then when you're implementing an RFC, you realize that just if-else conditions, you can see in this example, to manage the cache control reader, it's just conditions after others to be able to test every cases. So the same thing for the expires reader to check if it had already expired or always good to be served, for example. And another subject is the deployment. So the workflow. We have three parts. The first one is for the testing, then the building for the active artifacts, and the last one is to upload artifacts to GitHub and Docker. So everything is managed by the GitHub Actions. First, we are building the development container. We try to run the Golint, and after that we are running the Go test. Then we check the production container will be okay to be built, and we'll run with the current development. So first, I'm check out the code and validate statically the code, and I'm summoning a Docker environment with Go, and I'm creating, and I set up the Docker environment with the network. I'm building containers, and after that I launch the Go test, because I need sometimes I need all week container for the distributed cache, for example. After that, I validate that the production container is ready to be built, and for this, I'm just running the ls command inside the swan container, and if it's okay, it means okay, swan is running without crash, and it should be okay. After that, I've got two jobs for deploying. once a new tag is created. The first one is the binary generation to upload the Docker images to the Docker Hub using the login action from Docker. And it uploads the latest -full for the full version and just latest for the minimal version. And here is the result for the minimal version, for example. It's tagged as latest, and it's obviously pushed as the tag name, so like version 1.5.2, for example. After that, it is the artifacts generation to push the artifacts using the Go releasers to the tag inside GitHub, and it uses the tag name to build the name of the package, and it cross-platform builds for Darwin and Linux only, not Windows. And here are the results for Darwin and Linux, for example. Then after that, we are very happy with the community to see everything is green, everything works, and a new version is released, and it's awesome. So we are very happy in this case. So for those who want to see what is the power of Swan and performances, here are some metrics to view how many requests it can handle per second. It took around 35 seconds to serve each all 100 and 1000 requests. The max response time was 56 milliseconds, and the minimum one was 0 milliseconds, but it took around some microseconds to be done, but rounded to 0 milliseconds by Gatling, and it's due to the Badger powerful in combination with the asynchronous updates. So what's next in Swan? There is the official integration in KDE as KDE module and be part of the official documentation. The same thing for tech and increased performances, because when we are increasing performances, the community is happy, and improve the WordPress and PrestaShop integrations in the administration panel. And a new tagged version with this feature will be released as soon as possible. I can't tell you a specific date because it will take a little bit longer than I was expecting to be able to be released. And if you have any idea, feel free to open an issue on the repository. Then there are another cool side projects. The first one is Merge. It's an open source pen test oriented platform to be able to manage your missions about the pen test. And there are an API. There are an API and front. The API is written in PHP using Symfony, and the front end is written in Angular. And two other projects. The first one is PrestaShop Swan, and the second one is WordPress Swan. which are the integrations inside these CMS. To finish this talk, I just want to say thank you again to GopherLabsCon organizer team, and thank you to all of you who were listening me. Don't be shy. You can ask me whatever you want. I'll try my best to answer it. And anyway, I'm available on Twitter if you find some questions during the night. And like Gordon Ramsay is saying, thank you.
Uh, I will say it's a great project. If you are into the caching system, you wanna improve any this open source project, go contribute. So we have a last talk from one of Mahendra Bagul from InfraCloud. So let me share the you all. Let me share us. Okay, here we go.
Is demystify private certificate authorities using Google Cache. Let us get started. So before that, a little bit about me. My name is Mahendra Bagul. I'm senior software engineer at InfraCloud. You can find me on GitHub on this link. And my interests are around Kubernetes, Golang, and cloud native technologies. So while working on one of the assignment, I came across Google Cache and just wanted to share that information with everyone, what I learned there, and how you can also use Google Cache in your project. So let us get started. So the brief agenda for today is uh, in two parts, theory and demo. So we will quickly see what certificates are and how they are used, why should we they use them. Then again, similar things for certificate authorities as well, why, what, and how. And in the last, we will see how to manage certificate authorities using Google Cache. So in the demo, we will see OpenSSL based certificate generation, how to use OpenSSL commands to generate the certificates and certificate authorities as well. We will also see Google Cache dashboard. Okay, and then I will walk you through the code which I have for retrieving the CA pools from my account. Okay, so why should we use certificates, right? So you have these setups, client and server, and you also want uh, your communication between client and server secure, right? And that is basically achieved using certificates. So they are used in public key cryptography functions, also to initialize secure SSL connections between client and server, I just said, right? And they are also used to share keys, which are then used for public key encryption and authentication of digital signatures. So that's why we should use certificates. What are certificates really? So certificate is an electronic password which allows a person or organization to exchange data securely over the internet using the PKI. So PKI is a public key infrastructure. So PKI infrastructure has a private key and public key, right? So public key and private key, they are both related mathematically. So when you encrypt the data using public key, that data can be decrypted using the respective private key only. Otherwise, the data cannot be decrypted. And certificates are also called as a public key certificate or identity certificate. And the digital certificate will look like this. So it will basically have owner's distinguished name, owner's public key, and CA's distinguished name as well, right? And then you have something called CA, of which you need to use private key to create a certificate. Okay, so massive digest of these things and private key of CA, right? It will produce certificate. Sorry. Yeah. So there are different types of certificates. So we will first see server only certificates. In the server only certificate scenario, imagine that there is a server which you want to be started as a secure one. So you will need a .cert and .key file, right? So as a user, what you will do is you will create the private key and public key pair, right? Of and then you can either create self-signed certificates, or you can just get your certificate signed by some other entity, and that other entity is nothing but certificate authority, right? And these are basically some like allowed or like a public or well-known certificate authorities which are trusted by the clients. So you then sign your certificate using certificate authority, and then you use that .cert file and .key file to start your server. So once that is done, your client accessing your application from browser, it will need public key, or it will use public key to encrypt the data, right? And that encrypted data will be sent to the server, and then server will use its private key to decrypt that data. So this public key was available in the form of certificate, right? Which we just saw here, that the certificate will have owner's public key as well. So this is the flow in server only certificate, and then we just like talk about public key and private key here, right? The other form of certificates, or the other way of using certificates is MTLS. So both your server and client will have certificates. So as we saw in the last diagram, that server had certificates, right? Its own certificate. So similarly, client will also have its certificate. So here you can see client store, key store, and server has its server key store, right? And then when your server client is trying to access something from server, secure server, uh, client will verify server's identity, server will identify client's identity, and then client's identity, and then client will be able to establish the communication, and then the next flow will happen. So this is what happens in MTLS. So MTLS is nothing but mutual TLS, right? uh, Transport layer security, you can say. And there are different types of certificates, as I mentioned. So you have client certificates or user certificates, code signing certificates. So code signing certificates are basically used for checking the content integrity, right? Then you have email certificates, device certificates. Device certificates are basically used when you have an IoT based environment. So every IoT device will have its own certificate, and your server will not need any extra information to identify which device is trying to reach to the server. It can be identified. It can be identified by just reading the certificate of the device, right? And then there are object certificates as well. So how certificates are created, right? So they are basically created using OpenSSL and CFSSL. There are other tools as well, but these are pretty popular. So user is the person who starts. User is the entity, or I would say component, who starts the creation of certificate, the flow of certificate creation, and user will create private and public key. Okay, and then that public and private key will be sent to the next part, where registration authority will create a certificate signing request, CSR, and it will then send it to the CA, and CA will verify the user's identity, credentials. Here the spelling is wrong, but this is nothing but credentials. So CA verifies the user's credentials, right? And then post verification, CA will release .cert file to the user. So then user will have three files: public, private, public key, private key, and then .cert file. And then there is one more .csr. So four files in total. So why should we use certificate authority, right? So certificate authorities are used, like for example, if you we saw that example, right, where we had a server, and then public key, private key, and .cert file for it. And we if we hadn't used their CA, then we had self signed that certificate and then pass the cert file to client. Then client would have used the public key to set up the secure tunnel, right? But imagine that you have multiple servers and multiple self-signed certificates. So in that case, you need to share your public keys with your client. But if you are using certificate authority, you don't need to share those many .cert files. You just need to uh, use .cert file of CA and install it in a client's machine, and then that way your clients will be able to talk to your servers, right? So here you can see there is a root CA. Then there are two intermediate CAs which are signed by root CA. Then again, intermediate CAs are being used by the other certificates, or I would say this certificate 1, 2, 3, they have been signed by CA1 and CA2, right? So certificate 1, 2, 3, they are called as a leaf certificate because they are not able to sign any other certificates, right? So this root CA, this can be self signed, right? And then this intermediate CA1, it will be signed by the root CA. So this is how the certificate authority hierarchy looks like. So what are they actually, right? So you can call certificate authority as a trusted entity because that issues digital certificates, right? And also you can also term it as a attester, which can be trusted by an audience. So these are the few parameters which you can specify while creating certificate authorities: external validation, organization validated, and domain validated. So domain validated means your CN will have a domain entry there, right? Or the certificates for domains, certificates for organizations, right? Like that. So how should we use certificate, or how certificate authority is used, right? So we have already seen this flow, but let us go through it once again just to understand it properly. So there is an applicant who creates a private key and public key pair. Then applicant will use public key and its identifying information to create a CSR. Okay. Once that CSR is generated, it is then sent uh, to the CA. CA will validate the identity of applicant, and once that information is found valid, CA will use its private key to generate the .cert file, and then that .cert file will be sent back to the applicant, right? So this is the flow, or this is how certificate authority is used. Okay. So you can see here that the private key is playing a crucial role, right? And we need to keep this key in a secure place. So to do that, to store your private CA, we need to use Google Cache. So that is the prime reason behind using Google Cache, I would say. So you can either create CA directly on Google Cache, or you can just import them onto the Google Cache. Okay, so Google Cache, it is used to simplify the deployment and management of private CAs without managing the infrastructure. So it's a managed service from Google, right? And it also supports compliance with various regulations. So this is for country specific, I would say. And it also protects your Google Cache protects your keys in HSM. So whatever keys they are there for CA, they are stored in the HSM, hardware security module. You can use Google Cache to audit users activity. You can also scale with confidence as it's a cloud service, so you can scale it, right? And you can even enforce granular access controls, right? So I have already like answered this part, like what is Google Cache, but let me tell you again. So it's a highly available, scalable Google Cloud service. It simplifies, automates, and customizes the deployment, management, and security of your private certificate authorities, right? So how Google Cache is used, right? So you can have it your certificate authority or certificate on-premise infrastructure. Then you can import it to Google Cache, or you can just create a fresh root CA or intermediate CA on Google Cache. Okay, but when you create go intermediate CA on Google Cache, you need to like add your root CA, and in that case you need to like point to your root CA there. So let's see the demo one. So it is about OpenSSL. So we just need to see the commands which we can use to create the set of certificates. So here I have got a bunch of commands. So let me tell you the flow here. So I have got a root CA, InfraCloud root CA. Then I have InfraCloud intermediate CA, okay, which has been signed by InfraCloud root CA. And then there is a BotCube server CA, so sorry, server certificate, which has been signed by the InfraCloud intermediate CA. Okay, this one. And then there is a client certificate as well. Okay, so that is just for an example. So BotCube is a product from InfraCloud, and it basically like notifies you on Slack, Mattermost, and Microsoft Teams. So whichever cluster, Kubernetes cluster you have connected, or you have added your BotCube to that cluster, you will be informed on a Slack, on Mattermost and Microsoft Teams. So yeah, so I am creating server certificate for the website of BotCube. Okay, so here you can see I am using OpenSSL, using GenRSA algorithm, and here you can see I am self signing the root CA. So there are just two commands. I'm not creating .csr file here, but when I'm creating intermediate CA, that time I'm creating .key file, okay, and .csr file as well. Okay, and in the next command I'm using that .csr file, and then using ca create serial, and ca is nothing but InfraCloud root ca to sign my intermediate ca. So signing the intermediate ca by the InfraCloud root ca. Okay, and here in the server you can see botkube server.csr, and then I'm using the ca InfraCloud intermediate ca, right? And in the client as well, I should be using the InfraCloud intermediate C only. Okay, so let us run this code. So it will create bunch of certificates. So I need to first move to that folder, and then fire dot slash certs dot sh. So it will create. So the algorithm you might have seen, that's the default one, 4096 bit. Okay, RSA 4096 bit. And I think it is, yeah, it has created all the files. Let me just refresh here. Yeah, here you can see now root ca, intermediate ca client, and server certs, right? So before that I missed to tell you a few things here. So I'm referring this config file openssl.cnf, right? And also in the root ca I'm using this extension v3ca. In the intermediate ca I'm referring the extension called v3 intermediate ca. Okay, and in the server I'm referring the extension server cert. And for the last one, for client I'm referring the user cert. Okay, so these are the blocks defined in openssl.cnf file. So here you can see so in v3 intermediate ca, so it has a basic constraint as a ca true. Okay, oh, just 1 second, my yeah. So something happened here. Okay, yeah. So in intermediate ca, basic constraint is ca true and pathlane is 0. So pathlane basically decides how many levels you can create or you can sign the certificates. Okay, so pathlane 0 here means whatever certificates will be signed by my subordinate ca or intermediate ca, those certificates will not be able to sign the next set of ca certificates. So they are so whatever certificates will be signed by intermediate ca, they will be my leaf certificates. Okay, and in the user cert you can see the basic constraint is ca false. So this is not at all the ca certificate, right? So similar thing goes for v3 ca as well. This is the configuration for root ca. So here you can see ca as a true, right? And now yeah, so this should be my this should be the end of my first demo. Let us go to the second demo. So it is about Google Cache to store certificate authority. Yeah, so this is the certificate authority dashboard. So I have logged into my account, and here you can see I'm in certificate authority service dashboard. I have already created a CA here. Okay, by clicking on this button. Let me first walk you through these details. So I have this certificate of type tire DevOps, and location is Asia South 1. Okay, and this is of type root. Okay, so this is a root CA. I can create now intermediate CAs uh, or the leaf certificates by using this, or by using the certificate to sign them, right? Now if I click on this create CA button or link, I would get a form. So here you can see select the type root CA or subordinate CA. Then you can here add the details for the validity. So for how many days or years or months you want, or weeks, right, you want this certificate valid, right? Then you can basically choose from the tier. So DevOps and Enterprise are the two tiers available in Google Cache. So DevOps charges you $25 when you create the certificate CA certificate authority. Okay, Enterprise charges more. It is around $120, I guess. Then you select the region here. So I'm selecting here Mumbai. Okay, and then selecting DevOps here. So I'm not going to create a new CA here because I have already got one. So in the certificate issuance scenario, it means that for what purpose do you want this certificate. So this is just the part of this one, right? So whatever configuration I just showed you here, extended key usage, right, or key usage, critical digital sign signature, right, and then there should be extended key usage, yeah, client auth and email protection, right. So similarly, there are the types. For example, if I choose mutual TLS, then I would be able to sign server certificates and client certificates by this CA. Okay. So now I'm clicking on unconstrained, so I can create any kind of certificate or I can sign any kind of certificate. So I'm clicking on next. So I need to provide here the identifying information for my CA. So also adding pool ID. So it's a, I guess, random number, and here providing the CN as well. So this CA, I should give here IC root CA, InfraCloud root CA. Okay, and then clicking on next. So here I can choose the algorithm which I want. So when I had run that, run those OpenSSL commands, this 4096 algorithm was triggered, right, or used. So right now I'm selecting this one. And then here you can specify the CRL bucket. So certificate requisition list is a mechanism where you can this mechanism you can use to revoke the certificates which you have already issued, right. And the details can be stored in a cloud storage bucket. You can either specify a new storage bucket, or you can either use the existing bucket, or you can a new bucket will be created. Okay, then clicking on next. So here you can add any labels if you want. It's like a labels in Kubernetes. So you just need to, like, I mean, the identifying information you can add to this part. Then clicking on next, and here you will see the review summary, right? So whatever details we have added till now, those will be listed over here. So I am not hitting on create button. I'm just hitting on cancel because it is chargeable and I don't want to create a new one. Yeah, so let us go back. Yeah, it asks you for the for 2 times because whatever information you had added till now, that was a crucial one. So it just wants to make double sure that you are not by mistakenly clicking on a cancel button. So I will now go. I will now give you a little bit a background of or a few details from this created certificate authority. So I'm going inside it. So here you can see the detail which I had used while creating this certificate. I can also see the certificate.cert file for my CA. Okay, view certificate, and I can download it here, or I can just download the certificate, or I can just download the certificate chain also. So this is my root CA. So I don't have a certificate chain, or I will have the same set of same content in both of these files. But cert chain means all the cert files from your certificate till the root certificate. So if there are 5 levels, then 5 certificates will be there in the chain. Okay, and let me go back now. So a few things which I would like to tell you are here. So yeah, you can disable the certificate authority. You don't need to delete it directly, you can just disable it. So after you disable it, you can't issue new certificates using this certificate authority. Okay, as its name suggests. Also, when you click on this view issued certificate, you will see the certificates which has been created using this certificate authority. So I don't have any certificates created using this authority, so that's why no rows to display. But when you create certificates using this certificate authority, you will see the certificates here. Okay, so this is I would say the second the end of the second demo. Let us move on to the third demo, which is about using Node.js to fetch the details of Google Cache components. So let me move back to my code editor, and closing these files. Yeah, so here you can see in the package.json, I'm using this module, Google Cloud Security Private CA. Okay. So this is basically a wrapper, I would say, for the APIs of Google Case. Okay. And in quickstart.js, what I'm doing is I'm importing that package here, using it to create a client. And once that client is created, I'm accessing the list CA pools method. So what does it do is it needs one request object, and in that request object we need to pass the parent. So parent is a project ID and location, so it will return basically the list of CAs. Okay, so I just have got one CA in my Google Cache account, so I will just get one result here. Okay, and yeah, so this method is being so this is the async function, right? Self calling function. So whenever I will be running this program, run node quickstart.js, the call will be made to Google Cache service. Just reading it wrong. I unauthenticated, right? So that is happening because of my .json file. I also forgot to mention that I'm using one environment variable called Google application credentials, and it has a reference to my .json file. So this file is downloaded from your service account on GCP. So I have disabled my service account. That's why I'm not able to give call to this method. So otherwise you will see the list of CAs printed in the console when you run this program. And yeah, so I wanted to show you one more thing here. If you see, if I do control space next to client dot, then I can see bunch of methods here. So you can use this SDK to create a new certificate authority, activate existing certificate authority. You can also list the certificate authorities. You can even create certificates using this npm module. So what my point is that you can automate stuff if you want. You don't need to always go to the Google Cache dashboard and then get the things done, right? So you can achieve it through this npm module itself. So that should be the end of my third demo. Yes, and yeah, we are hiring at InfraCloud. You can go to this /career page, or you can send your resume at careers@infracloud.io. Thanks everyone for joining me for this session. Thanks everyone. Bye.
Thank you for attending this whole conference. Hope it's useful for you. Uh, Make sure check the tutorials, and subscribe to this YouTube channel for more and more kind of conference, more technical demos, and more educational material. Um, Thank you all.